Hello, this is Chuck Ridgway, Automation Technology Manager at Horner. Thanks for joining us for another Tuesday live stream. Now, a few weeks ago, I talked about the fact that in 2022, we're going to have a few weeks where we really get dialed into a topic, or we cover something with a little less scope and breadth than maybe we have in the past. Today is one of those weeks. Here's our topic: using Modbus TCP in a tag-based environment. Now, we've covered Modbus TCP a lot here in this channel, but one thing we're going to really zero in on today is if you're using Modbus TCP using advanced ladder, variable-based advanced ladder with Cscape, then we're going to give you all the information you need to know to properly apply that protocol in that environment. And joining me today is my colleague, Casey Gardner. How you doing, Casey?
Hey, not too bad. How you doing today, Chuck?
I'm doing terrific. Now, when I was researching for this topic, I just happened to kind of remember the fact that Modbus has been around longer than my career, and my career started in 1984. As a matter of fact, I think Modbus may have been around longer than you've been alive. Is that true?
Yeah, unfortunately. It's a dated one.
It's still perfectly valid, and it's widely applied today, even though it has been around a long time. So what are some of the issues with having kind of an older protocol like that we have to deal with today?
Well, just technology continues to move forward. So as we do, it's one of those things where there's been plenty of adaptations behind the scenes to make those older protocols or things that may have been dated still apply to today's technology, for that matter.
Absolutely. So most of the changes we've made have been really on the programming side of things, right? Or at least that's where some of the tools are a little bit newer. Yes, we still use ladder logic, which has been around an awfully long time, but the way we use ladder logic, as well as a lot of the other languages like structured text, etc., is a little bit more modern. But yet we still have to apply protocols that are based on some older technology. So today it's going to be all about how can we apply that really valuable protocol, but old protocol today in using some of our more modern tools. Okay, so Casey's going to be manning the chat today. If you have any questions and you're watching this live, just chat those questions in. If you're watching this on replay, then you can go ahead and get us your questions, but do so in the comment section. Okay, let's go ahead and get started. Okay, here's our agenda for today, using Modbus TCP in a tag-based or variable-based environment. I know at Horner officially we call it the Cscape variable-based advanced ladder, but I know a lot of folks in the industry tend to use the term tag. So whether I say variable-based or tag-based, I'm talking about the same thing. Okay, we're going to spend just a minute or two on a single slide doing a quick review of Modbus, because we covered a lot here on the Horner channel. We're going to talk about the Modbus data model because it's perfectly relevant for today's discussion. We're going to talk about those specific challenges when you're using a variable-based environment or a tag-based environment with a protocol that's more of a register or memory-based protocol like Modbus is. And then we're going to go through some specific strategies for implementing Modbus, whether you're talking about Modbus TCP as a server or a slave, or whether you're talking about Modbus TCP client or master. Okay, and of course, we're going to give you some demonstrations today. Today's demonstrations are primarily going to focus on the Cscape side of things, showing you how to configure and how to program. Okay, so quick Modbus review. Modbus is the most common industrial protocol that allows multiple manufacturers' products to talk to each other. So if you've got two devices from different manufacturers, you want to apply those in the same application, Modbus is what they would call the lowest common denominator, or the most common protocol for allowing those devices from different manufacturers to share data. Now, Modbus is applied a few different ways. Traditionally, it started out as a serial protocol, and it's still used that way widely today, typically over RS-485 multi-drop, using a form of Modbus called Modbus RTU. And then, of course, the most common way of integrating Modbus today is over Ethernet using something called Modbus TCP. Now, Modbus UDP also exists, but it's not quite as common as Modbus TCP. Okay, let's talk about that Modbus data model, because Modbus is, when it was invented, it was really modeled around a traditional PLC where all of its data was either Boolean based or integer based. Think about those early PLCs, and really PLCs to a great extent even today, where digital inputs, digital outputs, those are all Boolean based. Analog inputs, analog outputs are still, for the most part, integer based. So that's the environment in which Modbus was created. Now, when you talk about register addresses, Modbus happens to be a 1-based protocol, just like really the Horner OCS is a 1-based product as well. Any memory references that we have always start at 1 as opposed to starting at 0. And over on the right there, you can see a list of the 4 different types of Modbus data, as well as their addresses. And you can see that each section of data, each address, starts with a 1 as opposed to a 0. Okay, now the original Modbus address scheme, which is still the most common today by far, is 5 digits long. There is a 6-digit scheme that exists, is not as common. It's perfectly applicable if you're using that. So this content today is still going to be useful to you, but we're going to talk primarily about 5-digit addressing schemes today. Okay, what are the specific challenges with using variables or tags in your PLC programming environment or your OCS programming environment, and using really an integer-based, register-based type protocol like Modbus? Well, basically, Modbus is register-based and all the PLCs are variable-based. So that's the first challenge. They're different. Okay, Modbus is designed purely around integer and Boolean data. When it was invented, there was no 32-point floating, IEEE floating point data format. That didn't exist yet. Double integer data was way less common. Now, you can still apply Modbus with those particular data types, but it's not necessarily something that was there from the beginning. It was not in the original spec, and therefore some things can happen, such as manufacturers aren't always consistent with their word order. So if you're building a 32-bit floating point value or a 32-bit double integer value, you're basically going to be taking 2 Modbus words and concatenating them together. Well, what order do you arrange those 2 words? Okay, some manufacturers do it differently. So that can be a factor sometimes. Also, you have to take at least some care to ensure that you receive both halves of the 32-bit data simultaneously, because what can happen in theory is you could receive the lower word could be newer than the older word, which you may have received previously, and you could have a mismatch there. So those are the sorts of things that can happen, although in today's world, when with the faster hardware that we have and those sorts of things, it doesn't happen as often as you might think. So now let's talk about a specific strategy with Cscape. That's the programming package that's designed to configure all aspects of a Horner all-in-one controller. So let's talk about applying an OCS product, an OCS all-in-one controller, when it is a Modbus slave or a Modbus server. Okay, so that's the application where maybe there's a SCADA package, maybe there's a historian that an end user may want to use. So as an OEM, as a machine builder, I want to supply my equipment so that some of the important data that resides in my machine can be accessed by my user and applied with their SCADA package or applied with their historian package, just to name 2 examples. So in that scenario, I want to expose some of that data and make it available to those external products, and using Modbus or Modbus TCP is a terrific way to do that, because again, it's the most common protocol, so I can almost be guaranteed that my customer's equipment will interface to it in some way. Okay, so really what the job is in this application is, as an OEM, I want to create a published Modbus data map to make key information or key data of my machine available to the outside world. So that's what we're doing here in this first example. So first of all, in the Horner OCS, when we're using Cscape, we're really trying to get customers to start using some of the newer variable-based or tag-based programming languages. And the one we're talking about specifically today is variable-based advanced ladder. Now, with variable-based advanced ladder, traditional memory addresses and register addresses, they still exist in the OCS. They're just in the background. When you're creating regular variables in your program that aren't necessarily tied to real-world I/O or aren't being broadcast over a network, you don't need to worry with variable-based advanced ladder. You don't need to worry about where those variables might be mapped by Cscape in the OCS memory. It really doesn't matter to you. Where it does matter is when you are using real-world I/O, inputs, outputs, analog outputs that are wired to specific terminal points on the terminal strip. They have specific memory addresses that you need to be concerned about. But when you're just creating regular variables, that's not a factor. So with the OCS, since it does have a memory infrastructure, there already exists a fixed map between the OCS register space and the Modbus register space. And I've shown that on that chart right there. Okay, so you can see for the 4 different types of Modbus variables, Modbus coils or outputs, Modbus inputs, Modbus analog inputs, Modbus holding registers. For those 4 different types of Modbus registers, those are mapped to all the different types of memory addresses of the OCS. You can see those there on the right-hand column. Okay, so that map is done. There's nothing you need to do to change that map. Really what you're going to be doing in your application is you're going to be taking those variables that you want to expose to the real world and make available over Modbus, and you're going to use the variable creation tool or the variable editing tool in Cscape to map those specific registers to specific Horner register locations, which will make them available on specific Modbus memory locations. Okay, so again, to review, for real-world I/O that you want to expose to your customers, you don't have to do anything. So for I's, Q's, AI's, AQ's, all that real-world I/O, it's pre-mapped per that table to the right there, and there's no configuration virtually required. You do have to check a checkbox saying you want your product to support Modbus as a slave or as a server, but other than that, there's no configuration required. However, when we move to exposing other data, other variables that are important to be exposed for our customers, that's when we need to go to the trouble of creating those variables, which probably already exist in your application, and mapping those to specific memory locations in the OCS. And what I recommend that you do is just keep it simple. Yes, there are 4 different Modbus data types, but just use 2 of them if you can. Just use the holding registers, which are word length registers, and the output coils, as they're called, which are read-write Boolean type memory addresses. Just use those for your internal registers. And I would recommend that you go ahead, when you do your mapping in the OCS side of things, map those variables starting at R1 for your word type and longer variables, and map starting at M1 for your bit type variables. Okay, that will get them mapped over to Modbus 43001 for the holding registers and Modbus 3001 for the output coils. Now, if you're concerned about data being read-only in your equipment and you're worried about it being overwritten from the outside, you can use logic to prevent that from happening. For instance, if you have a Boolean that you don't want to be overwritten by Modbus, if you just use it as a coil in your application, in your program, in your logic program, then Modbus can't overwrite it because the OCS logic is continuously writing that coil. Similarly, with a, let's say, an integer or longer type value, if you don't want that to be overwritten, you want that to be read-only from your machine standpoint, then by using, a move function or some other function that's continuously writing that value in your program, it'll prevent Modbus from overwriting it. And by doing that, you'll eliminate a need to use input registers or input bits. You can just use those 2 types, and it keeps it nice and simple. What about 32-bit data types, you might ask? Because to represent floating point values, that takes 32 bits. To represent double integer values, that takes 32 bits. Well, effectively, that's not a problem. You just map the 32-bit variable to an R register. Remember, we're using R registers when we map to word and longer type references. You're going to map that 32-bit variable to an R register. Okay, it's just going to occupy 2 of them consecutively. Okay, and so ultimately what you'll be doing then when you're publishing your data that might include 32-bit data is in your machine documentation, you're going to document the fact, or you're going to publish the first Modbus reference for that 32-bit value. Okay, so if you look at the lower right-hand corner of the slide, you can see a couple of examples there. The data type, whether it's double integer or real, if we're talking about a 32-bit value. And then you're going to want to indicate, you probably should indicate, that it is data that has a Modbus length of 2 words. Because the Modbus spec says that all length has to be specified in words. So sometimes manufacturers get in trouble where they'll specify a 32-bit piece of data and then they'll specify it as having a length of 1. Well, that's not correct for Modbus. For Modbus, it needs to have a length of 2 because length is always in words. So when you do that, when the OCS is configured to be a Modbus slave or a Modbus server in the case of Ethernet, and it receives a read-write Modbus command, okay, it will properly react, and when the first Modbus address is referenced with a length of 2, it will return the proper value. So that's how 32-bit data can be handled. Okay, now let's talk about performing the mapping itself. How do I take my variable that I just created, that's a tag or a variable, and how do I actually map that to a specific OCS memory location? Normally, I don't need to worry about that if all I'm doing is, creating internal variables, which is the bulk of what I'm doing in my program. Well, basically, you get out the program variable editor, and you'll see that it has a memory column, and you can just simply, in that memory column, you can type in the specific address that you want to map that variable to. So as you can see there on the screen, the first reference I show there is a variable called machine mode, which is an unsigned integer, and it's mapped to %R1. And if you would go back a few slides, you would see that %R1 is mapped as Modbus address 43001. So anybody who is reading or writing that data externally over Modbus would use the address 43001. The OCS would then use the data that's stored in R1, and that data is tied to, through this map here, it's tied to that particular variable machine mode. Okay, so that's really what we're talking about there. All right, so let's take a quick look at a program for an XL4 that has been designed for applying Modbus as a slave or a server. Okay, so I'm an OEM using an XL4 and I want to publish certain data from my machine so that my customer can access that data with their SCADA or with their historian or some other way. All right, so let's take a look. And we're now looking at Cscape, and this is an XL4 program. Let's take a quick look at how you set up Modbus TCP, for instance, as a server. Okay, so we go to the hardware configuration dialog, okay, and we'll need to do that from the Ethernet location. We need to make sure our Ethernet is fully configured up here, so we have to have a valid IP address and net mask, and those can be variables assigned to, so that we can assign those from the touchscreen if we wish. And then there's one other check mark we have to make, and that is right here. Under resident protocols, we need to make sure we've checked Modbus slave. And then from a configuration standpoint, there's almost nothing to that. We make sure Modbus TCP is selected if that's what we're using. There's the default port, and we're good to go 99% of the time. So that's the network configuration side of things. Next, really all that's involved is taking the variables that we want to expose to the real world and with Modbus address space or Modbus addresses, and we want to make sure we map those using the memory column in the program variable editor. So here's where we do that. So I've got this machine mode, product select, volume select. These are all integer-based variables, so I've mapped them into nice consecutive areas in OCS memory. You always want to go consecutive where possible so that it's as efficient as possible for the external device to grab the data in as few messages as possible. So you don't want to have them mapped all over the place from a Modbus perspective. You want them in really as consecutive a memory locations as possible. So as an example, with this application here, I have what looks like only about 5 words that I've configured as and mapped to %Rs, which are available as holding registers. So with these 5 words I've mapped here, if that's all I have, a single Modbus holding register read with a length of 5 words could be used to read all the data in one fell swoop from this particular machine, which would be very efficient to be sure. Okay. And then from a Boolean standpoint, I really just have a couple of variables here that are mapped. Those are mapped into M's. And so if the outside device were to read, 2 consecutive coils, then they could get all the data here as well. So that's really all there is to it. Very little configuration under hardware configuration, just mapping to appropriate locations for the variables you want to expose to the real world via Modbus, really, and you're done. So that's pretty much all we're talking about when we're applying Modbus slave or Modbus server to an OCS product and using tag-based or variable-based Cscape to configure it. All right, now let's head back and let's talk about the next application. The next application is when we're actually going to be using variable-based Cscape with an application where the OCS is a master or the client. So in this case, it's the OCS that's doing the polling of slave devices or of server devices. And the goal is to get that Modbus data in and out of my variables in this scenario. Okay, so how do we go about doing that? Well, here's the process. So the first step really is to create a series of arrays for reading and writing the different Modbus variable types. So with Modbus coils, those are read-write. So we would create an array, given some reasonable name. On the screen there, I'm showing Modbus_coils. If there were potentially, let's say, up to 100 or so coils that you would need to read or write, you might want to put a length for that array of, let's say, 100 or 128 or something like that, some reasonable number. And then similarly, if you were going to be reading input bits, you would create an array called Modbus_inputs or something similar. If you're talking about input registers, you'd want one for an array for input registers. If you're talking about holding registers, which you almost certainly will have, that's the most common type, then you would create an array called Modbus holding registers again, or something similar. And coils and inputs are Boolean types. Input registers and holding registers are integer types. And then what you would do is you would map each of those 4 arrays, if you had all 4. If you only have one, then you'd only need to map 1. But you'd map each array to a convenient area of M's or R's. When I say convenient, what do I mean? Well, in variable-based ladder, for the most part, you don't have to pick your memory locations for anything. Really just real-world I/O. The digital inputs, digital outputs that are wired to specific spots on the terminal strip. But with Modbus, therefore, you're going to need to map it to an R or an M, so you might as well pick something convenient. So in my case, for this, what you see on the screen there, I mapped the coils starting at M101. I mapped the input starting at M201. I mapped input registers starting at R101 and holding registers starting at R201. So they're convenient because they're starting on kind of an even type number. So it's going to be easy for me to correlate which particular piece of Modbus data is going to ultimately be mapped to what variable. So those are the first 2 steps. Basically create some arrays, at least one per Modbus data type, and then map those arrays to R's or M's. The third step is you're going to go into configuration in Cscape, and you're going to configure the OCS as a Modbus master or a Modbus client, and then you're going to go ahead and use those arrays you just created as the local variables when you're reading or writing to Modbus address space to that third-party device or multiple third-party devices, okay? And I'll show you this in a Cscape demonstration here shortly. And then the final step is effectively to go back to your variable editor, add in whatever variables you're going to use in your program that you want to ultimately have tied to that Modbus data, and then map it into the appropriate register location. And we'll again cover that with a live demo here in a minute. let's go ahead and move to that demo now. All right, so here's what we're going to do in this particular example that I'm going to build from scratch for you. We're going to configure and program an OCS to interface with a fictitious motor drive that has a Modbus data map that you see there on the right. And this particular example we're going to do, we're just going to work with the holding registers. We're not going to worry about the other types for now. It's the same basic process if you're talking about the other types, all right? And then what we're going to do is we're going to create variables that are tied to the appropriate Modbus registers for commanding motor speed, commanding acceleration and deceleration, and also for monitoring actual speed, current, and torque. That's what we're going to do in this demo. So let's go ahead and get started. Okay, so I'm going to go ahead, switch to Cscape here. I'm going to switch to, let's go ahead and close this example we just reviewed here. Okay, and now what I have here is a new variable-based program. It's already been configured for an XL4. Let's start this process we just talked about. Okay, let's go back and take a look at that slide. Again, we're just talking about holding registers. So let's go ahead and do that first step, which is create that array that we can use for reading and writing the holding registers. Okay, so back to Cscape, to the variable editor. And when we're talking about holding registers, really when we're talking about any of the Modbus registers, we're going to do all of our variable mapping, and we're going to build all of our arrays in the retain variables. We're not going to do them in the global variables. They're going to be all done in the retain variable section. Okay, so I'm going to go ahead and add a variable. And ultimately what I'm adding here is an array. And I'm just dealing with holding registers. So I'm going to call this Modbus. Oops, let me get the proper keyboard enabled here. I'm going to call this Modbus hold reg. And I'm going to go ahead and I'll just leave it at that. Okay, so that's the name of my variable. It's going to be integer type. Okay, it's not going to be Boolean type. And I'm going to give it a dimension of, let's say, I don't know, let's say 100. That means I could ultimately read or write up to 100 holding registers using this array. So I'm going to have Modbus underscore holding reg index 0 through Modbus underscore holding reg index 99. That's what I've got capacity-wise. I could make that larger if I needed to. All right, and then let's go ahead and map that to a convenient location. Okay, it really doesn't matter where I map it. It just needs to be a convenient location. I'm going to go ahead and map it to %R1001. I could have just as easily used a different reference, but I'm using register 1001 in this case. Should make things easy to line up. Okay, so that's the first step. Create this array, and if I had other Modbus types I was dealing with, I would put in additional arrays here as well. Okay, now I'm going to go into the configuration. I'm going to make sure under LAN 1 that I'm configured for Ethernet, because that's got to be configured properly. I'm not necessarily going to check Modbus slave here, although an OCS can be at the same time a Modbus slave and a Modbus master, so that's not a problem. But to do Modbus master, or in the case of Modbus TCP, Modbus client, Modbus TCP client, I'm going to select Modbus client from the list here. I'm going to go to network configuration. I'm just going to go ahead and leave it at all the defaults. Now, I would always assign a status register here, so I'm going to go ahead and do that now. I'll call that Modbus client status. All right, and actually that's a disable network bit. I'm in the wrong location. I'm going to put it here under status, so let's call that Modbus client status, and it's 4 consecutive 32-bit words. So I'm going to configure that on the fly here. I'll configure that as double integer with a dimension of 4, because there's 4 consecutive 32-bit words there. I'm going to go ahead and make sure I don't forget to add my index since it is an array. Okay, and that's my top level configuration. From a device level standpoint, this is where I need to add the device as well as what is its IP address, and that could be a variable. It doesn't have to be hard-coded, although I'm going to go ahead and hard-code it here. I'll give this a name as, I'm just going to call this drive. Again, this could be a variable. I'm just going to hard-code it just to get this done with quickly. And let's say that's the hard-coded address there. I can leave the Modbus port the same. Now here, this is where we're going to configure the style of addressing that this particular slave uses that we're going to be talking to. And we're talking to, in our fictional drive, it uses the traditional 5-digit Modbus addressing. And then we can also enable slave status as well. I'm going to go ahead and call this Modbus server status. It's two 16-bit variables. We'll set them on the fly. Oops, let's try that again. Oh, it doesn't like me doing that on the fly. There's some occasions when you do have to configure certain things ahead of time. So for now, let's just go ahead and skip the Modbus server status. I would normally go back in and fix it, but let's just go ahead and leave it for now. Okay. So I've configured both the network side of things and the device side of things. Now let's get to that scan list. That's the next step. Okay. And let's add our information here. Okay. So what device are we going to be working with? It's the one device that we've configured, this drive device. What device register do we want to grab data from? Now, there's multiple ways that you can attack this. One way you can attack this is you can go ahead and, let's say, read or write one variable at a time to your drive. Think on that chart. If we take another quick look at that chart, you'll see we have what, 9 or 10 different pieces of data that are available to us all right in a row there. So one approach, which would be bad, by the way, and I'll tell you why in a second, one approach would be to have a different entry in our scan list for every single variable and have several different reads and writes to grab this data. That's one way we could do it, but it's the least efficient because we got to send the most messages over the network. Or we could, since this data is all consecutive, we could do a single entry in the scan list and read/write it all simultaneously, all in one message. Much more efficient that way. So let's go about that approach instead. Okay, so we're going to grab data starting at Modbus 40,001, and the length is going to be, if we go back and take a look there, we can see, if we add that all up, we're starting at 40,001. Our last piece of data starts at 40,011, but it's a real value, so it's going to take 2 consecutive words. So our length here, if we want to read all of this information, is actually 12 words. So we're going to set that length at 12. Okay, and then locally, that's where we use that array. Okay, that's where we're going to use our Modbus holding register, and we're going to start it at 0. So all 12 of these words are going to be read or written. Okay, they're going to be read as a matter of course, and if they change on the OCS side, they'll be written by the OCS as needed. But all 12 of those words are going to be contained within this array of data, which is 100 long. So it's really the first 12 elements in this array. We're doing a polled read write. And for this example, for this type of holding register data, we're pretty much done with the second step. We created our array in the first step. We mapped it over to internal OCS registers. We went into configuration and we set up an entry on our scan list for Modbus TCP as a client. Now the last step is just to go ahead and add some of these variables to our program. So we don't just have to use those Modbus holding registers index 7 or something like that for a variable. We can give it a more meaningful name. So let's start with the first one, which is the frequency command, which is mapped at 40,001, or the very beginning of the array. So I'm going to go back to Cscape, and I'm going to go back to my retain area of variables, and I'm going to go ahead and insert a variable, and I'm going to go ahead and call it, just call it frequency command. Okay, and it is a integer. And how can I be sure that I get the right data into this, that this frequency command is tied to the right Modbus data? Well, I'm going to do it by mapping it to the same location in the array. So my array starts with R1001 and runs through R1101 because there's 100 elements in the array. the first element in the array is where my frequency command is, is being populated. So therefore, I'm going to go ahead and map it as %R1001. Okay, so that's how I'm going to do that because it's the first entry in that array, so that lines up with R1001. All right, let's do another one. Okay, let's say we're not interested in all this data, but we're interested in at least some of the data. Let's go back to the slides. And let's say that we now also are interested in actual frequency, which is Modbus register 40,004. Okay, so it's the fourth element of the array is where actual frequency is located. Okay, so let's go ahead and add another variable. Okay, and I'm going to call this frequency actual. Again, it's integer, it's not Boolean. And this time, I need to map it to %R1004 because it's the fourth entry in the array that this particular data where that exists. Okay, so there we go. So I've created a much easier to understand variable name, and I've mapped it to the same location in the array where that data is being exchanged over Modbus. Let's do one more, but let's do a 32-bit one this time. So back to our slides. Let's say we want to do motor current, which if you look down the list there, you can see is a real number that's mapped at 40,007. So back to Cscape, we're going to add another variable. We'll call this motor current. Okay, and this is floating point data. So I need to assign it as floating point data. And then I need to map it to the right location in the array. And if we go back and look at that one more time, we see that it's the seventh word in the array is where that data starts. So that's where we're going to map it, is R1007 in this case. Okay, so we've done 4 quick variables, or I guess technically three quick variables: frequency command, frequency actual, and motor current. 2 of them are integers, 1 of them is a floating point. Okay, and because we created this array, which we can use for reading and writing words over Modbus, and we've mapped that array to a specific location in OCS memory, we can then create other variables that are mapped to very specific locations that line up properly with the array to get our variables where we want them. Okay, and I didn't do any logic or anything like that. It was all done through effectively variable creation and configuration. So that's pretty much what I wanted to cover with you today, showing you the 2 major approaches. Using Modbus as a slave or a server in a tag-based environment, or using Modbus as a master or a client in a tag-based environment. I'm going to go ahead and bring Casey back in. Okay, Casey, so what did you think about that approach to utilizing Modbus in a tag-based environment?
Yeah, I think it works pretty well. I mean, it's simple enough that, again, as long as you understand Modbus, it's not too hard to put it into variable-based form as well.
Absolutely. So I'm assuming we didn't have any questions today in our live stream.
We had one, and I went ahead and answered it in the chat.
Okay.
But just to repeat it, John was looking for where info for the enunciation for some of those status registers that you had discussed within the protocol configuration. Mm-hmm. And for that, we can easily find it either when you go in the protocol configuration, you can press F1, which will actually pop up immediately to a help page within Cscape for a lot of those. Mm-hmm. Or again, if you search within the help file for Modbus, I think we've got a couple different pages that go over those status registers as well.
Another good spot to find that information is the Ethernet supplement, which is a document you can download from our website. I believe you can find it kind of in our document search tool. You can also, I believe, find it in most of the product pages for OCS. So if you had an XL4 you were working on, you could go to the XL4 page on our website, go under the documentation section of the XL4 page, and then you would find, I believe, the Ethernet supplement on that page. And then the chapter for each particular Ethernet protocol, I believe some of the information you'll find in there is status information as well. So that's kind of another place to find that information.
We had one more question come in.
Sure.
From Peter, asking about if you're using register-based ladder in relation to basically a location above R10,000 as an example. We just ask them what the Modbus TCP would address then be. So in those cases, you would actually want to use the 6-digit Modbus addressing. Am I correct?
Yes, although I believe we might be limited still with Modbus to the first 10,000 registers being mapped to Modbus variables. So you might still be limited to R1 through 10,000. The first 2,048 are available with 5-digit addressing. The next ones between 2049 and 10,000, I believe, are all available in the 6-digit addressing, and then I don't believe available yet at all anywhere are registers 10,001 to 50,000. So I'm pretty sure those aren't available outside of the OCS via Modbus. Pretty sure that's correct.
Okay.
All right, terrific. 2 really good questions. Appreciate that.
Absolutely.
You bet. Okay, so a couple reminders. Don't forget to subscribe if you haven't done so already. Our subscriber total is climbing, which is great to see. Okay, and one of the benefits of being a subscriber, of course, doesn't cost anything, is you'll get to see, previews of when videos are coming out or live streams are going live, and you'll also get notifications if you ring the bell, of course, that we have a new video available, whether it's a live stream or whether it's one of our tech tips, which are extremely valuable. A couple other things. We're here every Tuesday at 2 o'clock, so don't forget to join us if you can. And of course, you can always watch our content on our YouTube channel on replay. And then next week, another one of our focus topics, we're going to talk about creating and editing tag-based variables, some of the tools you can use to do that. We're going to go in great detail about the variable editing window that I showed you briefly today. And we're also going to show you how to edit variables in mass if you would like to do it in a real efficient manner, maybe at the beginning of a project when you want to just get a bunch of variables into your program and use some sort of a text editor or maybe a spreadsheet or something like that to make that happen. Okay, once again, thanks for joining us at Horner for this Tuesday live stream. We look forward to seeing you next week, and please stay safe out there.